video, we're going to think about what goes on when a substance dissolves. We'll be going over a few vocab words like miscible, immiscible, partial charge, and the phrase like dissolves like. We should, by the end of this video, be able to predict whether substances will mix given their charge properties. We've already seen what dissolving looks like macroscopically, meaning what we are able to see with our naked eyes. But this is actually what's going on microscopically on the right-hand side of the screen. Water molecules are constantly moving around in liquid water. They're constantly moving. And for some reason, when water bumps into these solute particles that's put in water, it will attract it and it will pull it apart. So the solid clump of solute will separate until it is considered dissolved in the water. To explain this, there is a very important idea that I want you to know about water. Water is a partially charged molecule. Do you see the water molecule right there? You can think of each individual water molecule as an incredibly tiny magnet, okay? We can introduce or reinforce this idea rather by looking at a real life example on the left-hand side. Look at example A. Have you ever wondered why water balls up like that into drops? Well, the water molecules are partially charged there, but the leaf is not. Therefore, the water molecules are attracted to each other and they'll start to clump up into a sphere. It has to do with the positive and negative attraction here. Let's look at another interesting example below. Look at examples B and C. Have you ever wondered why some pitchers of water, why they pour so nicely, and some other pitchers, they don't pour correctly and they kind of roll off the side of the pitcher? Let's look at example B first. The water molecules in example B are partially charged, and the glass that the pitcher is made out of, it's not charged. That means that the water molecules are only attracted to other water molecules, so the water pours out nicely, okay? In example C, the water molecules are also partially charged, but the glass in the pitcher is actually manufactured differently. The glass is made of a resin or a component that is partially charged. So that means that the water molecules are attracted to each other water molecules, but those water molecules are also attracted to the glass, okay, because the glass is also charged. So when this happens and you try to pour water out of the spout of this type of pitcher, the water will be attracted to the glass as it's pouring out, and it will cause the water to roll down the side of the pitcher. Okay, that's how it works. In any case, the key idea here is that water molecules, they have a charge to them. Now let's look back at our example where a substance like table salt is dissolving in water. I've got a question for you. Why do you think salt breaks apart when you place it in water? I want you to pause the video for a short moment to collect your thoughts. So it has everything to do with charges again. NaCl, or table salt, it's an ionic compound made of charged ions. So water molecules are partially charged here, and NaCl ions are charged too. That means that water molecules are attracted to each other, and the water molecules are also attracted to the NaCl ions. Therefore, water can pull apart the ionic compound through attraction and also random motion. This brings us to a key idea. The idea is like dissolves like. It's an incredibly easy to remember idea, and it's super important. So this idea is, 1, a charged substance will mix well with another charged substance, like and like. 2, an uncharged substance will mix well with another uncharged substance, like dissolved like. But 3, an A charged substance does not mix well with an uncharged substance. So, do you understand why the phrase is like dissolves like? Here's a few more vocab words that I would like you to know. Miscible describes two liquid substances that are able to mix well together. An example is water and alcohol mixing well together. Immiscible describes two liquid substances that are not able to mix together. An example of this is oil and water not being able to mix together. You can see these examples with the two images on the right. I've got a question for you. If you know the rule like dissolves like, and the fact that water is a partially charged substance, can you predict if alcohol molecules are charged or uncharged? Do the same prediction with oil molecules. You might need a good minute to think about this, so I suggest that you pause the video. So the obvious hint is like dissolves like. Let's think about the alcohol example first. So let's look at the image with the alcohol and water. We know that water molecules are partially charged. We know that alcohol dissolves in water. Since alcohol dissolves in water, then alcohol must be like water. Alcohol is a charged substance. Let's think about the oil example now. So let's look at the image with the oil and water. Again, we know that water molecules are partially charged. We also know that oil does not dissolve in water. Since oil does not dissolve in water, then oil is not like water. Oil is an uncharged substance. Okay, it's that simple. I have some practice for you. In this practice, you're given a list of substances on the right and their charge properties. Basically, the substances in the gray box are substances that don't have a charge, and substances that are in the red box are substances that do have a charge of some sort. So, given this list of substances, predict whether the combination of the substances below will mix well or remain unmixed. The hint is like dissolves like. Take like 2 minutes to think about this, so pause this video. All right, so basically, if you have an uncharged substance combined with an uncharged substance, it will mix well. If you have a charged substance mixed with another charged substance, it will mix well too. But if you have a charged substance with an uncharged substance, those substances will remain unmixed, kind of like oil and water. Okay, I hope this helped.